So let's put our arithmetic sequences to work. So here we have a kind of standard form of writing an equation for the pattern of any arithmetic sequence. So this says a sub n, and this is a descriptor. It's kind of like when we talked about functions and we had f of g, same kind of deal. A sub n. This is an output here. So my output, what number in the sequence, what the number is, equals a sub 1 plus d, and then in parentheses n minus 1. So what do each of these pieces stand for? N is the number of the term. So I want the 4th term, the 10th term, the 20th term. A sub 1 is the first term. Remember that n stands for what term I'm talking about. D is the common difference. And a sub n is the value of the nth term. So again, here's my output. If I plug in n and I plug in these other values here, out will come the number of the value of the term that I'm looking for. Let's put this into use and see if it makes a little more sense. Write an equation for the nth term of the sequence, 1, 10, 19, 28. So we need to find the common difference and we need to find the first term. So the common difference here, again I'm adding 9 each time, so I have a common difference of 9. The first term is 1. We're just going to pull that right out of the sequence. So I'm going to plug those values into kind of my form of the equation here. A sub n, whatever term I'm looking for, equals the first term, 1, plus my common difference of 9, and then in parentheses n minus 1. So this is how we set this up. We always want to simplify this equation on the right-hand side. So we use our distributive here with our 9, and then we simplify. A sub n equals 9 minus 8. So this formula will help me find any term in the sequence, and I can always test it out on the ones that I know. If I was looking for the 1, 2, 3, 4, this is the 4th term in my sequence. If I was looking for the 4th term in my sequence, 28, if I plug a 4 in here for my input, I should get 28 as my output. So 4, 9 times 4 is 36, 36 minus 8, 28. So if I input a 4, I get 28 out. So this pattern represents this particular sequence, and I can use it to find the 100th term instead of counting all along. So let's see how that works if I want to find another term in my sequence that I haven't been given specifically. Find the 12th term in the sequence. So n equals 12. A sub n equals 9 times 12 minus 8. Again, I'm going to substitute in that 12 here. This is just representing my output, the 12th term. Substitute in 12 for n. Do my math over here on the right-hand side, and I end up with 90. So that my 12th term in this sequence, if I kept going, I would end up with that my 12th term was actually equal to 90. But I don't have to fill in all the missing terms to get there. All right, let's keep working with that same pattern here. That same a sub n equals 9n minus 8. Graph the first 5 terms of that sequence. So if you remember, my n kind of stands for, that's my input, what number of the sequence am I looking for? And my a sub n represents my output. What am I getting for that term, dependent on which one I'm looking for. So my input here will represent my n's, or what number of the sequence I'm talking about. My a sub n will represent my output. So I'm going to represent those on a graph as my input and my output, my x value and my y value, my domain and my range, my independent and my dependent. So on my x-axis, I've got my 1 through 5. On my y-axis, I need to represent all those outputs that I have, and I'm going to graph those points. Notice this is what we call a discrete graph. I'm not going to draw a line through it. You can look at it and see, oh, it definitely has a constant rate of change. If I was going to draw a line through it, I would have a nice straight line there. So it's linear, it's still a linear function that we're talking about. I'm not going to draw a line through these, however, because the line represents an infinite amount of points, whereas we are only talking about these particular points. I don't want to talk about, in this pattern, 1.5 means something, because I'm not going to have the 1.5 term in this particular sequence. So having 1.5 as an input doesn't really mean anything, so it doesn't make sense to draw a line through them. We have certain points that matter, we have certain discrete points that matter. We're only going to graph those particular points, but we can still see that constant rate of change of that slope. What is the term of the sequence? What term of the sequence is 172? So I'm going to plug 172 in here where my a sub n is. And I'm going to figure out what the n is, what term is that. So here I have the output and I'm working backwards to find the input. So plug in 172. We are going to then do our algebra and come out with 20. So this is the 20th term in this particular pattern. So again, going back to that original pattern of 1, 10, 19, 28, if I got all the way up to 172, that would be the 20th term.